Welcome to day 11, file handling. In day 10, we have learned how to handle text and CSV files. Now we are moving to uh, something special called JSON, XML, and YAML files. How we handle them. In modern data platforms, you will handle files that aren't just rows and columns. The reason is APIs most of the time prefers JSON to transfer their data over the wire. And so whenever you are at the receiving end of the data, which is coming from APIs, you are going to receive a JSON. We also have a separate video for handling JSON. We have metadata and orchestration configs which are written in YAML. We have legacy systems or ERP exports that still use XML. XML was an original form of transferring the data. Like almost 10 to 15 years back, XML was extensively used. We used to have ask in interviews that, okay, do you actually know XML or not, and all. So we used to ask that syntax, and still many legacy system carries that syntax, and therefore there is a possibility that you might get a configuration files in XML. For example, in Informatica, there are many places where you can find XMLs. So in many legacy system, in Oracle system, also we find XMLs. Most of the time they are used for configuration and all, but yeah, they play a very important role. And even to store the data as well. Earlier it was used. Now JSON is the modern form of XML, you can say. Understanding these files and their handling is very important for a data engineer. Let's start with the first, JSON. JSON is JavaScript Object Notation. That is the full form of JSON. It is the most common data format used today. It's lightweight, readable, and directly maps to Python dictionaries and lists, and therefore it is very important to learn the JSON handling. I have already placed one JSON file in volume, in Databricks volume, and what I'm just trying to read is just trying to read that file with open in a in a read only format. I read that file and load it into a variable called data using a function called json.load. There is a complete library in Python, import JSON, that we have imported, and we'll be using that library. Once the data is available, now what you can simply do is you can iterate over the data. So what gets created is the list of object, and that list of object you can iterate one by one. Let me just list of object or dictionaries, you can say dictionary get created, and that dictionary you can then iterate over one element after the other, and you are just printing this out. Let me do two more print statements. Let me try if this works. Let me print data, and let me also print employees. Just this. Okay, let's see what happens. So I just wanted to showcase like what kind of data set is loaded here, and at the same time what we are iterating. So yeah, I think we are good. So let's see. Let us try and understand. We printed what is loaded from the file. Even though the file is in form of JSON, what JSON.load has done for us is it has converted that entire JSON file into a list of dictionary, into a dictionary basically, into a dictionary. So this is the first print that we are seeing. The second print that we see is this. So then each element is iterated over. Like this is the first element, then this is the second element, and this is the third element. Okay, so this is how the iteration works, and in each iteration you can very easily get the data separated out for your work. JSON.load parses file contents into native Python objects. If you already have JSON text in the string, use JSON loads. Okay, now we are going to write a JSON. On the similar lines, we'll just reverse the operation. What we did here is we just imported JSON library. We are now adding elements to a JSON string. So what we are doing is we already have this 1, 2, and 3 already there. Now we are going to add 1, 2 and 5 is there. We are going to add 3 and 4. Let's add 3 and 4, and let's add 3 and 4 and we'll write it down. To the same file variable f, f is containing, one second, data is containing that variable, and we just read that file, and within that there is a separate file which I have put here, employees out.json. We are reading that file, and to that file we are just adding these two more elements, and we are able to successfully write it down. If we just wanted to view that file again, let me simply copy this data. Let us try to read that file. What we will do is we'll just copy the path of employee out.json. Let us take this, okay, and json.load, and we'll do the print data. Let's see what happens. Okay, you can see that the element 3 and element 4 is written successfully here. Okay, so this is how it works. Great for incremental ingestion and metadata appending. Why it is said that whenever we have whenever JSONs are mostly used for storing the metadata, we use it many times for metadata operations and storing, and therefore this is very important format. Moving on to, I think I have done almost similar thing here where I'm just trying to insert something. I'm just trying to append a value 5 in it, and then we are again reading it back. Let me try to run this. This works out, and then we are also able to see that the element Raj is now added. Now see, there is no duplicate check or something, right? So let me add it again. You will see that one more Raj will get added. So like that. Okay. So we have seen that we can read the JSON, write it back into the JSON, and again read the same file back again. So this is how it works. Moving to the next set of format, which is XML. XML is extensible markup language. XML is common enterprise. HTML is common in enterprise system like ERP, banking, SAP, even some legacy system. Those verbose is still widely used for configuration and legacy integrations. So what I've done is I have stored one simple employees.xml, and we'll try to read it. So there is a special library in Python called XML tree and element tree that we can use to iterate to go through the XML and read it out. XML always have certain property, like XML will have something called root element. We always need, if you want to parse or go through an XML, what we have to do is we have to go to that root element first, and with reference to that root element we then try to get the actual information. So like this. So first of all, we tried to find out all the root elements whose name is employee, and then that array is iterated with the help of a for loop. And once that element is there, you can take the information out of that, like in emp.find name. Within that employee there is a name node, and there is a salary node. uh, Let me see if I can quickly show you that XML uh, which I have stored. Let's go to catalog, and then let's go to data engineering data. I have stored it somewhere. Let me check. I think I stored it here. Employee dot xml. Yeah, this is the one. They are saying that it's not supported, but let me try to open it for you, and you can see that there is a root element called employee, and inside that root element there are two such elements. So the array would contain two elements, and then it has the child nodes as id, name, and salary, like that. Okay, let me just expand so that you are able to see. Right, so employee, then ID and seller. So this is the parent node and these are all the child nodes. So what this code does is it will try to find all nodes which are having name as employee, and through that it will try to read each and every child node and get the and extract the information out of it. This is the standard way of reading the XML. Similarly, you can write it down. Like what you can simply do is just create similar structure with the help of similar library. So, for example, now you are creating an element. So we go to the root element, and to the root element we add a sub element called employee. Now we add an employee number 3 with the name of with a different name and a salary, and then we add that element to the tree, and then we recreate that file and store it back. So this way you can do the XML read and write operation. There are some elements that for like easier management we can convert Python XML to dictionary, because what happens is every time going and finding out something from XML takes time. It's a time consuming operation to parse through the XML, right? So to avoid that, what we generally prefer is we simply convert that to a known format. Dictionary is known to Python developer. We have seen many of the exercises where we have used dictionary. So Python developer or data engineer is most of the time familiar with dictionary. So we simply convert any XML to dictionary, and then we just iterate over it, or we can very easily manage that. Okay. So what we do for that is we read an XML file, we get to the root, and to the root element we tell that okay, find all such elements under the root element. Under the root element, find all the elements which are named as employee, and then convert them to pass them on to this function called XML to dictionary. And then for each of them, keep on collecting such record into these records. So you can imagine that this complex structure of XML is converted into a simple dictionary. Now with this you can very easily proceed with the code of looping or conditional statement, control flow, anything you can very easily manage. Moving on to the another format called YAML. So this has recently been popular, not very recently, but at least few years now, but very extensively used. YAML is a popular configuration and metadata handling type of file in Airflow, Databricks, Docker, ML Flow. It's like a JSON, but more human friendly. It's much human friendlier than the JSON. So Airflow uses YAML a lot. Databricks has their new product called DABS, Databricks Asset Bundle. It extensively uses YAML. YAML. Okay, YAML is very friendly and a much popular syntax. Just to tell. So we I just wanted to introduce that to you in a simple way so that you can, if you get to read YAML, how to process the YAML. Okay, so I have, as always, I have stored one employee.yaml here, and you can read it with open, and then simply what you can do is you can iterate through that. Okay, so there is a library called YAML. So we are just using import YAML, and YAML.safe-load is loading it into a config, and through config you can very easily point to different elements in the YAML. So let me just quickly open that as well. Employees.yaml, let me check. Employees.yaml, is it open to open it? Yes, this is it works like that. Okay, so this is the parent node called pipeline, and under that pipeline node you have something, you have like configurations like name, source, destination, and then transformation is an object, and transformation object has its own childs. Okay, so like that. Now if you want to reference, with reference to this, you can very easily understand how we are referencing it here. So config pipeline name. So if you wanted to print name, so we can simply pipeline name. So we are referencing it with first parent and then child, pipeline name. Like that, pipeline transformation, like pipeline and then transformation. And if you want something inside transformation, let us use remove duplicates. Okay, now transformation is an array, so we won't be able to go directly into it, but yeah, yes, this way you can very easily represent. Okay, so moving on to writing it again. So similar on the similar lines, you can create a dictionary, and you can use the same library to dump the data into YAML. Okay, moving on to a mini data engineering scenario, as we always do at end of our topic, mini data engineering scenario. Let's connect it all. Read YAML config file, load JSON data, and write a CSV. Okay. So what all things we are doing, we'll see. So we are going to read one YAML file. So I have already put like employees config.json, employees config.json. So we'll read employees config.json into config, and then read JSON file as well, read the JSON file as well, and write it, clean and write it in a CSV. Okay. So we have read this employees config.json. Let me just try to see it. Last time I ran it ran. Let me check. Okay. Clean and write a CSV. So this is just a attempt to see if we are able to understand everything. So we just use employee config.json. Let me see if employee config.json is here. Employee config.json is employee config.yaml is here, and you can see this is the content of the file. Now what we are going to do is we are going to read it, and also we are going to read something like a JSON file as well, which is a source file. Yeah, we are going to write it into a JSON, and we are going to write it into a CSV. So let's just check. Uh, Clean and write CSV. Yeah. So with open, uh, we have a target file where we can write it down. So what we are going to do is we are going to use the elements, like whatever we read from the YAML file, source file, whatever the value that is present, we are going to read that value. Target file, whatever value that is present, we are going to read that and use that to do the operations. So we read everything from config. We are reading the element called source file. So we'll read this value. So this entire thing will be replaced with this volume location, and that which is employees.json. So employees.json will be open in a read only format, and data will contain the data from employee.json, and target is employee clean.json. So this file will be replaced with this value. So we'll read from employee.json. Just let me copy this, and so that we are able to explain it in a better way. So we are going to read from employee.json, and we are going to write it into employee clean.json. Okay, so this file we have opened it in the read only format, and this file we are opening into write mode. Okay, once that is done, what we will be doing is we'll read the configuration from here and convert the CSV into dictionary writer. Okay, CSV dictionary writer, and then we will write each and every record by record. We'll start writing it down. Once that is done, each and every record will be saved in the CSV. So let us check employee clean.csv, employee clean.csv, what is present in employee clean.csv. See, ID, name, and salary. ID, name, and salary data is properly written in employee clean.json. Okay, so we read the configuration from here. We use that configuration to load the data from employee.json. We read the data, perform certain operation, and then return that data. Like we perform certain operation as in strip and title, simple operation we are performing. We perform the simple operation strip and title, and return that data back into the target location, which is which is employee clean.json. You have seen the data is written properly. So this is a simple example of how the configuration files are used. Instead of just storing this data here, what we simply do is we will just pass the configuration file, and the configuration file will have all the locations, all the possibilities, and whatever configuration that you wanted to be used here. So this is how we do. Okay, so this is a perfect example of how YAML file can be used as an configuration for ETL. Congratulations, you built a multi-format ETL pipeline using YAML for configuration. As I mentioned, YAML for configuration, JSON as an input, and CSV as an output. So this is what we were trying to build it out. So this is how advanced file handling works, and this finishes our video for advanced file handling. In the video 10, we have seen how we handle text file, and then how we handle CSV file. In this particular video, we have seen how we handle JSON, YAML, and XML files. These are the 4 or 5 file types around which the entire data engineering scenarios work flows. There are certain advanced formats like Parquet and others, Parquet and Delta, that we will discuss in when we move to Spark. That comes in Spark. But whenever you are dealing with Python, these are 4 or 5 formats. You will play around this only. Okay. So thank you guys for listening. This is day 11 where we learn advanced file handling. In day 12, we'll go to some of the more advanced topics. Till then, please do subscribe. Thank you.